We can also do type conversions, which basically just means that you take one type and convert it into another. So if I take an int x that equals 12, I can convert this into a double y that equals x. And so basically what this will do is it will force this x, which is a 12, into a double, and it will look like something like that. And you can also do this another way by saying, in a little bit less direct way, if I create a string, just name this str, and if I put string here and then say x, and C# is saying that you don't have to actually explicitly say this because it has that toString method. But if you wanted to convert an object into a different thing, you can either call this function toString if you're wanting to convert it into a string, or if you want to say take this int and make it into another double, say double x. And this is just yet another way to turn this int x into a double. But most of the time you can do this implicitly, and you do not have to actually specify what you're trying to convert it into. Problems come when you try to convert something and it's going to lose data. So if you're trying to convert something double back into an int, then you generally get trouble because you're losing data, and you have to do this cast because you have to say, okay, I actually want to lose data, and I purposefully am doing this, and I know the consequences of doing this. It also looks like if you were to create a new object, and I were to assign this the old value of FTI, what this actually does is it leads to both of these objects pointing to the same variables in memory. So if I had a function that allowed me to change the feet that I put in, then I would actually end up changing the feet for both of these two objects. They're both linked up together by the same variables, and they're pointing to the same location in memory. There is a way, at least in C++, that you can overload this sort of assignment. It's called the assignment operator, and you can actually make it so that way you do not end up copying the location of those two variables. You want to actually have two separate copies, so that way if you make changes to one, it does not affect the other. So that problem of copying data members, it comes when you have a class, but if we change this instead to a struct, then C# knows that we're wanting to actually have two separate variables, and when we're doing a copy like this, we do not want to do a shallow copy where it's just pointing to the same variables in memory and we're creating two separate objects. And that is an introduction to types in C#.